different cations and anions here, and we're going to practice making sure that we've got the right combinations of these atoms. This will give you a chance to look through it also. You'll notice that everything in the cation column is positive of some sort. Everything in the anion column is negative of some sort. Let's say you weren't sure about that. We're going to go back just a minute. If you aren't sure of how positive or negative something is, use the tall columns as your guide. This is a great thing to have written on your periodic chart. The first column, the alkali metals, they are positive ones. They like to lose 1 electron. The second column likes to lose 2 electrons. The third column, and by third column, I actually just mean aluminum. Now, these guys also will tend to lose 3, but aluminum specifically is always +3. And then these can be a variety, but +4 is one of the options, but it can be a variety, so I'm not going to put a label on that column. I'm going to put -4 now, though, to represent what happens here in the blue section, and then -3 is what happens in the blue section, and then -2, and then -1. And these guys like to have no charge if possible. So let's go back. These already have the charges for you, but you can see like Na is plus, Cl is minus. Again, here's where Na is, it's +1. Here's where Cl is, it's -1. So when you combine a +1 and a -1, and if your goal is to be neutral, you only need one of these and one of these, because a plus and a minus makes you 0, which is what we use to represent neutral. We'll write NaCl. Now we have, in this case, a 2- and a +1. So you can think of it as like +1 times x, and then -2, and we want it to be neutral. If you need an equation, there you go. Most people can kind of think this through in their head, though, and they can be like, oh, look, I just need 2 +1s to match my 2 -1s. And here's how you represent when you write it. So you write the letters, and the 2 that's in front, that tells you how many of these that you need. I'm going to do one more example, then I'm going to let you practice. Now we have 3 minus and a +1 charge. So you're going to need 3 positive charges to balance these 3 negative charges. And again, the 3 in the front, Na3P. So now I'm going to let you go ahead and fill out the rest of this. If we look over here on this side, this is a group. You just treat it kind of the same way as you treat the Cl, unless you need to indicate that there need to be a lot of them. If there need to be a lot of them, you need a parentheses. So I'm going to show you an example where there needs to be a lot of them. So right here we have a 2+ and a -1. I need 2 of the -1s to balance my 2+. So when I put this over here, I have Ca, and then I have NO3, and then I have to have a parentheses to put a 2 in there. Look, if you don't put that parentheses, it looks like 32 to begin with. There's no way you need 32 oxygens. The other thing is it doesn't really look, it's hard to see that that 2 applies not just to the oxygen. So there are 6 oxygens in this, but it also applies to the nitrogen. Oops, 2. So go ahead and fill out the rest of this, and we'll see how you did.